All right, so today I'm gonna go over the pre-processing steps for this project I'm working on, which is the Bird Song Classifier with machine learning. I won't go into too much details about the background, motivation, and the data set. You can read them on my website. I will include the link below. Just a quick reminder that the data is sourced from Berkeley 2023 Kaggle competition. And I cannot share the dataset with you, but if you're interested, you can go to this link here and click on the data tab. You will need to create an account or sign in and accept the competition rules, and then you will be able to download the datasets. I'm working with the train metadata.csv and the train audios only. So to get started, I already created this Google Colab worksheet, and I am going to, the first step is I will import libraries. So the first one I want to do is to grant myself drive access, since I saved the dataset into my Google Drive. I will need to mount my drive, content/drive. And let me just run this real quick. It's gonna ask me to connect to my Google account, so I'm gonna do that real quick. So now my drive has been mounted, and I will now import the standard libraries. Which is NumPy and pandas. And I will also import libraries for processing audio, since we're working with audio files. So the first one is I'm going to import the audio from IPython.display so that I can display the audio files. And then I'm also going to import Librosa, which is a library that I'm going to use to work with audio files. And one of the processing steps that I'm going to do is to split the pre-processed CSV into train and test. So I'm going to use scikit-learn for this. And so I will import the scikit-learn library here. Selection, import, train, test split. All right, so now the libraries are imported. I'm going to load my CSV file. CSV. So my metadata.csv is saved in my Google Drive project folder, which is right here, you can see. So I'm going to use pandas to load it up. And my path is content drive, my drive project. And the name is train CSV. I load it. I'm just gonna take a look at the first 5 rows. As we can see, the CSV file was loaded successfully, and here is the first 5 rows of the CSV dataset. Here we have some, columns like the primary label, type, location, and most importantly, the file name, which is where the audio files are saved. They're in the OGG format. So for example, the first one, is gonna be under abather1 / this is a file name itself. All right. And let's just take a look at the primary labels real quick. We can see here that there are 264 unique primary labels, which is consistent with what we saw from the Kaggle competition dataset descriptions. All right, so next step, I'm going to start doing the pre-processing. And on my website, I listed the pre-processing steps that I plan to work on. So the first one is I want to include only the 3 species that I selected. Which is Barthwa, Kamsin, and Iwag Wang, I believe. So to do this, I will first put them into a list. Interested species. Okay. And then I will filter my original data frame to only include interested species, to include only the 3 species that I'm interested in. So after I do the filter, I just want to take a look at the first 5 rows. And we can see that, originally we started with the Abather Wang, but after the filter, you can see that we're starting with Barswa. And let's just take a look at the primary labels real quick to make sure that the filter was successful. And we can see that the original 264 species have been now successfully down-filtered to only the 3 that we're interested in, each with 500 instances. All right, and then for step 2 of the pre-processing, I'm going to remove duplicates. And how I identify duplicates is if the rows have the same duration, location, type, primary label, and author. Okay. So the first step is we can see that in the original data set, the duration element is actually missing. So we know where the files are saved at. So we can extract the duration from each of the OGG files using librosa. So the one is to extract duration using librosa. Okay. And before we can extract the duration, we want to set the top level directory path so that we don't have to keep writing the same path over and over. So I'm just gonna type it out once to save time. Content drive. My drive project. And let's just, so all the audio files are saved in the train audio folder, as you can see here. So my path is gonna be train audio. Okay. And to load up the audio files using librosa, I also need to specify the sample rate. So I'm going to use sample rate 16,000 for this project. Let's just select an example to make sure that the path works, and I'm able to load the audio using Librosa. So I'm just gonna create a new variable called example. So, just a quick example. Right, so this is the first instance of the file name from our filter data frame. It's XC113914, and we can double check that it's the first rung in the filter data frame. Okay, so now I'm going to load up the audio using Rosa. Upload. And I need to give Librosa load the path. So if you're interested, I have already put up the documentation here. So we need to specify a path and the sample rate. So here for the path, it's gonna be the top level path plus the file name, which is just example here in our instance. And we need to specify the sample rate. When we specify the sample rate, Librosa will automatically resample the audio file using the specified sample rate. Otherwise, it will sample at 22,050. And let me just use audio to load up the audio. Audio, and I need to specify the rate. Sometimes Librosa takes a minute to load, so we're just gonna wait for it to load. And the audio file was loaded successfully. So now that I know my path is correct, I'm going to define a function that will help me get the duration. I'm also gonna use Librosa again to get the duration. Here is the Librosa.getDuration function. So I'm going to specify y, which is the audio time series, and the sample rate. I'm going to give a file path and the sample rate as input. So the sample rate is the default set to 16,000 here. Path and sample rate. And to get the duration, I will use the Librosa.get duration. Since Librosa also has a get duration, I'm just gonna change my function name to get audio duration just in case I get confused on which function I'm calling. And my function is going to return the duration. Okay, and so I'm going to use a lambda apply to apply this function to each row of my filter data frame. And save it in a new column called duration. Okay, apply. Duration X. Okay. Let me see. So I am applying each of the file name from each row into as an input to this function, get audio duration. And my file path actually needs to be updated to include this path. So I'm just gonna put the path here. And I think that's it. So this is going to take a few minutes because we have 1,500 rows in our data frame. While it's loading, I'm just going to set up some of the checks that I want to do after this has been loaded. So the first one I want to do is to check the data type of the duration column to make sure that it's as expected. And we'd probably want to take a look at the first 5 rows of the filter data frame with the duration column added. I am going to pause recording here and I will come back when this has finished. All right, I'm back. So now this has completed. It took around 8 minutes here, as you can see. There is some warnings here I'm just going to ignore for now. And the first thing I want to do is check the data type is a flow 64, which is what I expected. And I wanted to take a look at the first few rows to ensure that the duration column has been added successfully. All right, so the next step I want to do is to find duplicates. Okay, remember that I mentioned earlier that to find the duplicates, I need to find rows with the same duration, location, type, primary label, and author. So for the location, I'm going to use the latitude column. Okay. I'm going to create a new variable called duplicates. Duplicated. So we have the duration, latitude, type, primary label, and author. And I'm going to set keep equal to false. And I would want to inspect. Oh, I would want to get the duplicate rows from the duplicate, not duplicate, filtered. Yeah. So I'm going to save this into duplicated rows. There. And let's take a look at how many duplicated rows there are. And also take a look at just the duplicated rows. And something happened. I mistyped this. Okay. Okay. We can see that there are 15 rows. And if we inspect, for example, the first 2 rows, we can see that indeed they have different file names, but they have the same duration, the same latitude, the same types, the same primary label, and the same author. All right. So I already looked at this previously, but if we scroll down here, we can see actually, for example, for this instance, we have 3 rows that could be duplicates of the same recordings. So to confirm whether these are indeed duplicates, I'm going to inspect them real quick using Librosa. All right. So remember earlier that we were able to load up the audio using Librosa load by following the path. So I'm going to do the same thing again here. I'm going to play duplicate 1 and duplicate 2. The path is the top level directory path plus duplicated rows file name .0, and I need to specify the sample rate, which is 16,000, and I will display the audio. Okay, and then the same thing for the second row. I'm just going to change this to get the second row. And I will play these audios to make sure that they are indeed the same audio clips. And after listening to the audio clips, I can confirm that they are the same. So next step is I'm going to remove these duplicates. Remove duplicates. Okay. So before I remove duplicates, let's just take a look at how many rows there are. We have 1,500 instances before we remove the duplicates. And I am going to remove the duplicates by using the drop duplicates function. And we're going to use the same subset as we used earlier. Let me just scroll up so that we're using the same subset. And what do we want to keep? We want to keep the first instance of each of the duplicates. And I'm going to replace my original filter data frame with this new data frame where the duplicates have been dropped. So once I do that, I'm going to display the length again, the number of rows again. We can see that here we have 1,492 rows, which means 8 duplicates were dropped. Let me just review this real quick and count how many I would expect. So we have 1, 2, 3, 4, 5, 6, 7, 8. Indeed. So there were 8 duplicates that were dropped. Okay. So then now we have finished the second step of the pre-processing. So remember, the first one is we filtered to include only the 3 species that we're interested, and then we removed any duplicates. And then step 3 is we want to split the data frame into train and test. So to do this, I'm going to use the scikit-learn train test split function, which is super convenient. It's going to shuffle the data frame for me and split into train and test based on the percentage that I specify. So remember earlier, I already imported a library, which is the scikit-learn train test split function. So I'm just going to use that here. And my test size, I want it to be 30%, and I'm just going to set a random state so that this is reproducible. Let's take a look at the number of training instances and the first few rows of the training data frame. As you can see here, that the data has been automatically shuffled. We have ComSen, EWAC, ComSen, Barswa, and we have around 1,000 instances. And I'm going to do the same thing by taking a quick look at the test data frame as well. Indeed, the test data frame was also shuffled, and we have around 450 instances. So now I am going to save the pre-processed training and test data frames for future use. I'm going to use the pandas to CSV function. So I'm going to say train df.to CSV, and I just need to give it the file path. I'm going to copy what I wrote earlier. I am going to save it as in a project folder as traindf.csv, and I want the index to be false so that it doesn't automatically create an index column when I save it to the CSV. And I'm going to do the same for the test df. And let's run this. So now these should have been saved. Let's go to the project folder. I think it's going to take a minute for it to show up. And you can see here the train df and the text df have shown up here as CSV files. And I am just going to load up these CSV files real quick to make sure they were saved as intended. All right, so this is the train df that I reloaded from the CSV. And if we want to compare to the original one that's right here, you can see that they're the same CSV files. And I will just do the same for the test. And again, for the test CSV as well, it's as expected, the same CSV file that was saved. I'm going to delete these two rows. And that's it for the pre-processing steps. Thank you for watching.